In previous lecture, we discussed one of the application of derivatives, which was curve sketching. Now we will address one of the problem which we encountered in chapter 2 while finding limits of the function. The problem arose when we got infinity by infinity or 0 by 0 form. These are the few indeterminate forms and we can solve them with the help of derivatives. The L'Hopital's rule provides a straightforward technique to evaluate limits of indeterminate forms. Applications of the rule often converts an indeterminate form to an expression that can be easily evaluated by substitution. We can apply this rule to indeterminate forms of type 0 into infinity, infinity minus infinity, 0 raised to the power 0, 1 raised to the power infinity, infinity raised to the power 0 as well. The first two indeterminate forms, 0 into infinity and infinity minus infinity, can be reduced to the forms 0 by 0 or infinity by infinity using algebraic transformation. The indeterminate forms 0 raised to the power 0, 1 raised to the power infinity, and infinity raised to the power 0 can be reduced to the form 0 into infinity with the help of identity. Now, what is actually the L'Hopital's rule? There is a rule using derivatives to calculate the limits of fractions whose numerator and denominator both approach 0 or positive infinity. The rule is known as the L'Hopital's rule. Suppose that f of a and g of a is 0, that f and g both are differentiable functions on an open interval I containing a, and that g dash of x is not equals to 0 on the interval if x is not equals to a. Then limit x approaches to a, f of x by g of x is limit x approaches to a, f dash of x by g dash of x, assuming that limits on the right side of this equation exists. As long as we get the form 0 by 0 or infinity by infinity at x equals to a, we continue to differentiate f and g. But as soon as one or the other of these derivatives is different from 0 at x equals to a, we just stop differentiating them. Now, we have to note that the derivatives of numerator and denominator are taken separately. Now, how can we apply L'Hopital's rule? It's very simple. We have some p by q form. When we apply, when I try to substitute x approaches to a, that particular value in the function, if I get 0 by 0 or infinity by infinity form, then I can apply L'Hopital rule. In that, I have to treat f and g as a separate functions and take their derivative. After taking their derivative, I'll apply the limit. If I'll get an answer, exact number, it's good. If I don't, then if I get once again 0 by 0 or infinity by infinity form, then I'll take the derivative again and I'll take the derivative again and again. Now, these are the few indeterminate forms: 0 by 0, infinity by infinity, infinity into 0, and all of these can be solved by using the L'Hopital's rule. Now, here is an example. Here is a function written in the form of p by q. F of x function is 3x minus sine x. G of x function is x. If I'll substitute 0 here, I'll get 0 by 0 form. So here I'm applying the L'Hopital's rule. I'm taking the derivative of 3x minus sine x, which is 3 minus cos x. I'm taking the derivative of x, that is 1. Then I'm substituting value x equals to 0 in this expression. I'm getting a value of 2. So this is the limit of the function. Now, here sine x by x square, substitute the value here, I'll get 0 by 0 form. So after getting this form, I'll take the derivative of sine x, that is cos x. Derivative of x square is 2x. Substituting the value, I'm getting infinity. So this is fine. Now ln x by 2 under the radical x. Substituting the value of infinity, I'm getting infinity by infinity form. So I'm applying L'Hopital's rule here, taking the derivative of ln x, that is 1 by x, taking the derivative of 2 into under the radical x, that is 1 by x, rewriting the expression. After rewriting the expression, substituting the value, I am getting 0. So this is the limit of the function. Now this is infinity minus infinity form. So in the start I told you that by doing some algebraic manipulation we can convert infinity minus infinity form into 0 by 0 form. So here I'm taking the LCM, so the expression becomes x minus sin x by x sin x. If I'll substitute the value 0 here, I'll get 0 by 0 form. So I'm taking the derivative of x minus sin x and x sin x. I'm getting this answer. And once again, if I'll substitute value here, I'll get 0 by 0 form. So once again, I'll take the derivative of numerator and the denominator. After taking the derivative, I'll substitute value of limit. So I'm getting this value. So this is the L'Hopital's rule. Okay, as I have already said that sometimes the intermediate forms infinity into 0 and infinity minus infinity can be handled by using algebra to convert them to 0 by 0 or infinity by infinity forms. Uh, Sometimes we may have a function f of x raised to the power g of x. So when you apply limits that lead to the indeterminate form 1 raised to the power infinity or 0 raised to the power 0 and infinity raised to the power 0, so they can be handled by first taking the logarithm of the function, and we use the L'Hopital's rule to find the limits of the logarithmic expression and then exponentiate the result to find the original function limit, original functional limit. So this is the way we can solve them. Like if we have f of x raised to the power g of x, so what we will do is we'll take ln of f of x and find the limit. If it is equals to L, then limit x limit x approaches to infinity e raised to the power ln f of x. Ln f of x is replaced by L, so we will get a limit of e raised to the power L, and a may be either finite or infinite. So here we are applying L'Hopital's rule to show that limit x approaches to 0 from the right side. 1 plus x raised to the power 1 by x is e. Now this is f of x, this is g of x. So if I'll apply 0 directly, I get this indeterminate form 1 raised to the power infinity. So 1 raised to the power infinity. So I'll take f of x equals to 1 plus x raised to the power 1 plus x, and find limit x approaches to 0 ln f of x. Since ln f of x is ln 1 plus x raised to the power 1 by x, applying the log property 1 by x into ln 1 plus x. Now applying the L'Hopital rule, taking the derivative of ln 1 plus x and derivative of x, substituting the value directly in the expression, I'm getting 0 by 0 form. So I'll apply L'Hopital rule. I'll take the derivative of ln 1 plus x and I'll take the derivative of x. I'll get 1 by 1 plus x after substituting the value. Okay. So after substituting the value 0 in the expression, I get 1. So the value of ln f of x is 1. That is e raised to the power L. So e raised to the power 1 is e. So we have proved that 1 plus x raised to the power 1 by x is equals to e. Now here is another indeterminate form. Substituting value here, I'm getting infinity raised to the power 0 form. This is an indeterminate form. This can be solved by using the identity which I have previously discussed with you. Let f of x is x raised to the power 1 by x. I'll take the limit of ln f of x. So ln f of x is 1 by x into ln of x. Now this is f of x, this is g of x. Substituting value directly here, I'll get infinity by infinity form. So I'll use L'Hopital rule. Derivative of ln x is 1 by x, derivative of x is 1. Substituting the value here, I'm getting 0. So this time the value of ln f of x is 0. So e raised to the power 0 is 1. So once again, x raised to the power 1 by x limit is 1. Now here are some questions which I have solved for you people, so you can try to solve them by yourself, and after solving them you can check your concepts by solving the worksheet questions.